Okay, it's Mr. Rops, and we are going to work on the theory behind the calculations of the binomial distribution. And so if you are taking math applications for the IB, this theory behind it is not part of the curriculum, but it could be helpful to understand what is going on. So let's consider this problem here. We're looking for the connection between the binomial theorem and probability. Well, you may not even know what binomial theorem is, but hopefully we'll shed some light on what's going on here. Consider cereal boxes, where 20% of boxes have a prize and 80% do not. And I'm going to buy 3 cereal boxes. I'm going to draw a tree diagram to demonstrate all the possibilities. So what happens is I buy my first cereal box, and there is either a prize or there is not a prize, like this. And I'm going to call not a prize, I'm going to call that Q. And so having the prize is 0.2, and not the prize is 0.8, which happens more often. This is the first box. The second box now goes, I could get the prize, or I could not get the prize. Similarly, I could get the prize, or not the prize. Okay, so this is the second box. So I could go prize, 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 not prize, and so on. And finally, the third box, 0.2, Q, 0.8, P, Q. This is 0.2, 0.8, P, Q, P, and Q. 0.2, 0.8, 0.2, 0.8. Okay, so now, if I consider this scenario, I know that if I go down this scenario here, I won a prize, a prize, and a prize. So 3 prizes. If I've gone this way, I've gone 2 prizes, and a fail. If I go this way here, I go prize, fail, no prize, prize, no prize. If I go down this path, I get a prize, no prize, no prize. This one here is no prize, prize, prize. And this I go no prize, prize, no prize, no prize, prize, no prize. And then I can go no prize, no prize, prize. And finally, the last one is going to be just no prize, no prize, and no prize. And so these are all the possibilities that can happen. And so, but if you look at it, there is one way that this can happen. There are 3 ways that I can have 3 fails and a positive one. There are 3 different ways to have 2 prizes and 1 fail, and then 1 way to have 3 prizes. And so these numbers are counting how many different scenarios there are. But when I find the probability down this tree, it's just going to be 0.8 times 0.8 times 0.8. So this is 0.8 to the power of 3. When I go and look at the red scenario, where I go fail, prize, fail, they all are going to have 1 prize and 2 fails. Similarly, when I do the green scenario, where I go prize, prize, fail, or prize, they all are going to, again, they're going to have 0.8 to the power 2, so 0.8 times 0.8 times 0.2. Now, I could go 0.8 times 0.2 times 0.8, depending upon the way it's written out, but it all ends up being the same configuration of probabilities. Okay, so, and then finally, for the last one, it's going to be 3 prizes, which is as such. Okay, and so you can start to see patterns exist. Like if I want to get 3 prizes, it's this. If I want 2 successes and a fail, well, here's 2 successes and a fail, 1 success and a fail. And so these exponents add up to the number of trials you're going to have. And if I generalize this, I often have like the probability of success to some power r times some failure to, well, these two numbers had to add up to, I know this was my 3rd trial, this is my 3rd trial, this is the 2nd trial. Well, it's going to be, if I'm going to have 3 trials, these numbers add up to 3, it's going to be n, which is my trials, minus r. And then there's always some kind of value in front here, which counts how many ways it's possible. And this is n, choose r goes in front. And this here is a whole nother calculation, but it ends up getting 1, 3, 3, or a 1, depending on the situation. And so if I was going to do the probability of exactly 1 prize, I do the probability of exactly where I want 1 prize, probability of 1 prize. Well, I would take n is 3, r is 1 prize, and this is going to count, this calculator is going to count 3, and I'll talk more about that in a bit. And the probability of success was, well, I want 1 success and 0.2. I know I'm going to have 2 failures, so it's going to be 3 minus 1, which is going to be 2. And so to get this number here, and I could just put this in the calculator, it will figure it out, but to get this number here, well, okay, to get that number here, well, if I consider going to the 2nd row here, this was success, success, there was 1 way to do that. Success, fail, fail, 1 way to do that. This is success, fail, success, fail. There's 2 ways to do that. Here it was 1 and 1. And so if I start to look at these numbers, 1, 2, 1, 1, 3, 3, 1, 1, 1, there's a pattern that exists. And I'm going to write it down in a different way. Here's the pattern. It goes 1, 1, and then 1, 2, 1, and then 1, 3, 3, 1. And then it's going to go 1, 4, 6, 4, 1. So if I was going to draw 4 cereal boxes, this would be the pattern of the combination. So my 4 cereal boxes, I could have 4 with a prize, all 4 with a prize, or I could have 3 with a prize, or 2 with a prize, or 1 with a prize, or 0 with a prize. There is 1 way to have 4 prizes. There are 4 ways to have 3 prizes. There are 6 ways to have 2 prizes, 4 ways to have 1 prize, and 1 way to have 0 prizes. It goes on to 5s, and so on. And you'll note, if you see the pattern, these 2 add to get that. 1 gets 1 here. 1 and 2 makes 3. 2 and 1 makes 3. 1 makes 1. 1 and 3 makes 4. 3 and 3. 1 and 4. They all add up. And this is a famous triangle. It is called Pascal's triangle. And this triangle enables us to calculate this value. And so when you put in your calculator this value, if you want to find it, you go math all the way to probability. You're going to do this one here and number 3. And so you're going to go like 3, choose 1, and that will end up being 3. And it just looks at the triangle to find those values. So if you want to know how the calculator does it, that's what it does. It can count how many different combinations you can have your successes, and then it multiplies the probabilities out. That's a quick background on how the calculations for binomial distributions are calculated, but if you're doing applications, you don't actually need to know this.